I'm going to begin this lesson with reviewing briefly what we learned at the end of last lesson. Protons, neutrons, and electrons. Our protons are positively charged and they're found in the nucleus. Our neutrons are neutral subatomic particles that are also found in the nucleus. And then electrons are negatively charged and they're found outside the nucleus. And we'll get more specifically into how electrons and where electrons are formed and found. But atomic number is the number of protons in the nucleus of the atom. And so with the atomic number, it also identifies the element. Every element has a different number of protons, and therefore that tells us the atomic number. Now, the atomic number on the periodic table, if I have a little sketch of an element, and let's see, I'll pick carbon, 6C, and this is 12.011. This number here is my atomic number. And that also tells me always the number of protons. Atoms are electrically neutral. At this point, we will learn about ions, but atoms themselves are electrically neutral, which means my number of protons needs to equal my number of electrons, or my number of plus ones needs to equal my number of minus ones. Mass number is the total number of protons and neutrons in the nucleus of an atom. So I have atomic number, I have mass number, but then I have a combination of these two words, and I have what's called the atomic mass. And this number here on the bottom of the periodic table, this is my atomic mass. We'll go into specifically how that number is determined, but very, very roughly at this point, it's the number of protons and neutrons because those are contributing to the mass. But we understand that we can't have fractions of protons and neutrons, and so we'll learn in the next lesson why those numbers are decimal numbers. So, a sample problem. How many protons, neutrons, and electrons are in an atom of Be9? Well, what you need to know is that this 9 here is the mass number. And the mass number, do you remember what that is? The mass number is the protons plus the neutrons. So if I'm looking at this, the only way to do it is to look at a periodic table. So you should have a periodic table next to you for the rest of this lesson. So go ahead and pause and get one because that will make the most sense for this. So I look up BE on the periodic table and I notice that the top number is 4. If the top number is 4, that tells me my number of protons. My protons are 4. If it's neutral, because it's an atom, then my electrons must also be 4. And then if protons plus neutrons is 9, then I must have 5 neutrons because 9 minus the 4 gives me the 5. So 9 is my mass number, 4 is my protons, so 5 is my number of neutrons. So let's go ahead and try another one. And I'm going to wait a minute, pause the video, and answer this one yourself. How many protons, neutrons, and electrons are in an atom of neon 20? Okay, hopefully you looked up neon on the periodic table and you saw that neon was element 10. So if it's element 10, it has 10 protons, then it'll also have 10 electrons, and if we're going to find the number of neutrons, we're going to go 20 minus 10 and end up with 10 neutrons. Ions. An atom or group of atoms, because we have learned about our polyatomic, right? Many atoms. So an atom or a group of atoms that have a positive or negative charge. Most of our polyatomic ions were negative except for ammonium, which had a positive 1 charge. An ion has either gained or lost electrons. It doesn't change in protons. The charge comes from either gaining or losing electrons. A positive ion that has lost electrons, and we call them cations. So a positive ion has lost electrons. If we lose something that is negative, we will have more positives than we have negatives. And a negative ion has gained electrons. So we've brought on something that's negative, and so it's an anion. So how are you going to remember this cations and anions? Well, if you think about it, there's cats. And what do cats walk on? And people always say feet, but I don't want you to say feet. I want you to say paws because your cations are positive. So let's take a look at this chart to fill in, and we'll fill in a lot of these charts to make sure we understand all of these different things. The symbol of this element here is Li, so it's telling us that it's lithium. So you need to have your periodic table next to you, and you look at this and you see lithium, and you look at the periodic table, and the atomic number, the number on top, is 3. So that's my number of protons. Protons is also always the same as the atomic number. Oops, I'm sorry about that. And so there, my atomic number, those columns are always going to be the same. My mass number is my protons plus my neutrons. And so here, protons plus neutrons, 3 plus 4, gives me 7. Okay. This touch screen is really getting to me today here. So 7. I don't know why it's doing that. To find my electrons, remember my charge is plus 1. And if my charge is plus 1, then I have more protons than I have electrons. And so I must have one more proton than I have electrons. It's weird to think of electrons. And so in this case, my electrons are 2 because I need to have 3 things that are positive and 2 things that are negative in order to have a charge of plus 1. Let's take a look at this next one. I have my protons, which means I also have my atomic number, which is 35. Once I have my atomic number, I can go ahead and look on the periodic table for that element. So go ahead and take a look and find that element. Okay, did you find it? So 35 is bromium, so I'll put in Br. I don't know why it keeps switching like that. I thought I had fixed it. And so my neutrons are 80 minus 35, which would give me 45. Now in this case, my electrons are minus 1, which means I have more electrons than I have protons. I have 35 protons, which means I must have 36 electrons. Now if I look at aluminum, I'm going to go ahead and look it up. And why don't you go ahead and try to fill those 2 in on your own, and then we'll come back and see if we got the answers right. Okay, did you get them correct? Aluminum is element 13, has 13 protons. The charge is 0, so my protons and electrons are the same. My mass number is 13 plus 14, so it's 27, and my atomic number is 13. My last one is oxygen. It has 8 protons. Again, my protons and electrons are the same, so my charge is 0, and my atomic number is 8. So valence electrons, how to draw a basic atom, okay? To draw a basic atom, we're going to draw our nucleus, and we'll just draw a circle. Wants to give me a pen here. So it wants to draw, we're going to draw a circle, and we're going to put the number of protons that's in the middle. And so I'm going to start with carbon. So we're going to have 6 protons. Now here's my periodic table. So I have carbon, 6, 12.011. 6 is my number of protons. To estimate my number of neutrons when I don't have a mass number given, I'm going to look here because this is approximately what I have. So if this is 12, I'm going to round this to the nearest whole number, which is 12. And so that must mean that I have 6 neutrons in most of my carbon atoms. When I go to put electrons on, the first ring can only have a maximum of 2 electrons. Every other ring after that can have up to 8, but if I have 6 protons, then I only need another 4 electrons. We're going to learn later in this unit that atoms don't really look like this. They don't really end up exactly like this with these rings of electrons. However, it is useful for us to talk about in terms of explaining things. So if we're going to look again, let's take a look at something like argon. So here I have argon, and it's AR, and it has 18 electrons and then 39.948. So here I'm going to put 18 protons in the center, and this is almost 40, so 40 minus 18 gives me 22 neutrons, and then I need to add my electrons. They have to be up to 18. I put 2 electrons in my first ring. The max the next ring can hold is 8. And then I have 10, so I need another 8. I'll put another 8 electrons on the third ring. If I needed more electrons, let's say I was doing something like potassium, which had 19, I would go ahead and put 1 electron. And this is our basic drawing of an atom. Now, if we're going to draw electron dot diagrams, we need to look at what column they're in. And so if I look at something, all of my group 1s that form +1, or all of them have 1 ring in the outer shell. So if I look back here at my carbon, I look at what is in the outer ring. And this outer ring for carbon has 4. And so any one that has 4 electrons in the outer ring is going to end up with 4 dots around it. So we will look at this more closely, but basically any element that we have, we're going to draw the outer ring of electrons. And we put the first electron here, the second one here, and then we just start alternating the sides. And so it doesn't really matter as long as my first 2 are together, and then I can put my third one, my fourth one, my fifth one, and then start again with 6, 7, and then 8. And so for carbon, if I go back, carbon has 4 electrons in its outer ring. I'll make a letter C to represent carbon. And then I would put my first electron, I'd put 1, 2, 3, and then 4. If I wanted to do this for argon, argon has 8 electrons in its outer ring. And so I would put AR, and I'd put 1, 2, 3, 4, 5, and then double back up, 6, 7, 8. And the most electrons I can have in a dot diagram is 8.